Everybody. So we are going to learn about function notation today. And we are on number 20 in unit 2 on functions. So a couple of key words and key phrases are what are functions? So just as a quick little reminder, we have learned that a function takes an input value. Ooh, let's see if we can get this to work. So an input value and assigns it exactly one output value. The four ways that we can represent a function are the following: are graphs, mappings, a table, or ordered pairs. So that's just a quick little rehash. And so now we're going to talk about what is function notation. And it is the relationship between the input and the output. So we normally write this as the function name, and then inside the parenthesis will go the input, and it will all be equal to the output. So just like this. So for example, h of 5 equals -2 will have a function name of h. The input value is 5, and it has an output of -2. The other example has a function name of d with an input of x, and it has an output of +9. All right, so we're going to play with this idea of inputs and outputs, and also these function names. And this is how you will write function notation. All right. So moving on to our second part here, function notation with graphs. Based on a graph, you can find its input by looking at the horizontal axis, and we're going to look at the output using the vertical axis. So the graph d of t to the left represents Gulliver's distance from home after t hours. So d of t is our function, or our function name is d. Our input value is t, or time, and our output will be the distance from home. All right, so based on that information, if we want to figure out how far from home Gulliver has gone in t amount of hours, we look at the input. So d of 5 means that Gulliver has traveled for 5 hours. So we're going to come over here on our graph at 5 hours, and we're going to look up on our graph to see how far of a distance did he actually travel. So we're going to come up, and we notice that right here at this top corner shows how much distance he has covered. So over here, we are going to look at what is that output value. So that output value is 11 meters from home. Okay, so let's try number 2, where it says d of 2.9. So what we're going to do is off here to the side, we will go to 2.9, which is close to 3. So we'll go about here, and we're going to follow our function upwards, and we hit the function there. And we're going to travel across to see how far of a distance is that. So it looks like 4 meters he has moved. All right, so now let's reverse the things. We're given an output of 5, and we're looking for what input would give me that output. So instead of going on the time axis, we're going to go on the distance axis. So we're going to go a little bit something like this. So we're going to go up to 5 since he's traveled 5 meters. And we're going to come over to our function and see how many times do I touch 5 meters as I'm going across. So I notice this spot I touch, and oops, not there, Miss Weldy. This spot I touch. So as we come down, we're going to figure out how much time does that occur at. So D of 4 would represent an output of 5. And we also have a second one, which lands right in between 8 and 9. So we're safe to say that D of 8.5 can also give us an output of 5 as well. All right, now last but not least, we're looking for what value of t would make our distance of time t equal to 0. So where am I 0? Now there's a lot going on here. So at time that our distance is 0, it means he hasn't moved. Here, how much time has gone by? Well, when he initially starts, aka 0, 0, so when time is equal to 0, his distance would be nothing since he never left the house, but he also returns back to the house within 10 hours. So 0 hours, and it looks like about 10 hours worth, he would have no more distance away from home. All right, so according to that statement, D of 7 equals 10 means that in 7 hours, whoa, that looks horrible. In 7 hours, Gulliver is literally 10 meters from home. Now, how does function notation work with mappings? Well, for our mappings, we have our inputs and our outputs. So for every input, we're going to map it to its output. So if I have A of 30, that means I'm going to go to 30 as my input and map it to its output, which is literally 25. A of 40 means my input is 40, and according to this mapping, my output should be 35. Okay, now we need to go A of what input would give us an output of 15. So let's take a look here. If I have an output of 15, then my input should be 10, according to my mapping. And what is x when A of x equals 45? So that means my output of x is 45. And as I look at my outputs of 45, I follow back my arrow to my input of x. So x would have to be 20 in order to have that output of 45. Now let's take a look at these ordered pairs and function notation. So down below, match each function notation with the equivalent ordered pair. Well, if I have f of -1 equals 1, then -1 is my input and +1 is my output, which means this function notation would match with -1, 1. So same thought here. H of 2 equals 7 means that we have an input of 2 into the function, and our output is 7. So that should match the first coordinates, 2, 7. All right, the third guy here, g of 1 equals -1, means in the function of g, we're putting in 1, and we're getting out -1. So that's this guy right here. And last but not least, we have the last one here, v of 7 equals 2. And we should connect it with 7, 2, input, output. All right, last section, which is the tables. So our first example is a function of h of a represents the average height of boys that are A years old. Use the table to evaluate the following. So h is my height of 7, which means for 7 years old, what is the average height of this young man? So 7 years, let's look at our table here. Our average height looks to be 49. So our output is 49 inches. If I look at when a young boy is 11 years old, that average height is 57 inches according to our table. Now let's look at part C. If my average height is 39 inches, then how old would the young man be? And according to our table, our output is 39, so our input has to be 3 years old. All right, and then we have, what is the age of a young man when he can be 51 inches tall? So according to our table, we'll go to our outputs of 51, and it looks like A is going to have to be 8 years old. All right. So according to this last question, it says using this function of f of x equals 3 minus 4x, fill out the table of values below, and then we'll also evaluate the following function notation. So if I wanted to figure out what is f of x when x is -6, you'll use your function. So off to the side here, we'll use our 3 minus 4, and in place of x, we are going to put -6. So we use our -6 as our input, and now we use our order of operations. So instead of subtracting, we're going to multiply first. So multiplying a -4 times -6 gives us a positive 24, and we add 3 to that, so our f of x is 27. So let's do the same thing for an x of -3. So as we input -3 in place of x in our function of f of x, we would use the order of operations again. So -4 times -3 is positive 12, and we'll add the 3 from the front to get positive 15. Now let's do the same for 0. If we did our order of operations correctly, which is multiply, so 4 times 0 is 0, and then we take 3 minus 0, we get 3 as our output. Now let's do 1 as our input as well. And we should come out with an output of 3 minus 4, which ends up giving us -1. All right, now this last question, though, it reverses our process. If we know the output is -5, they're asking you for the input. So to figure this out, you're going to have to use the equation from up above. So our output is -5, or f of x, and then we're solving for x. So we're going to have to subtract 3 from both sides, and we'll have to divide by -4, which means our x value has to be 2. All right, now let's fill in our table, or our function notation. So f of -6, what is its output? Well, we found it to be 27. F of 0 was positive 3. And who came out with -5? Well, our input, or x, had to be a positive 2 for -5 to be our output. And last but not least, what x value gave us -29? Ooh, we need to find that. So we're going to come back to our function of f of x, which is 3 minus 4x. And in place of the output, we're going to put -29. So then we can solve for x for our input. So again, we'll subtract by 3 and divide by -4. And -32 divided by -4 is a positive 8. So x must equal 8. All right, now it's time to practice.